Today we're going to talk about designing and performing experiments. So your second FRQ on this exam that you're only going to have 15 minutes for, you're going to have to design an experiment. So what they're going to do is they're going to have a list of equipment, and you have to pick the list of equipment, and you have to explain, you have to describe an experimental procedure that you would use, and you have to be very specific with measurements and other things, and how would you use the equipment and everything that you would do. So let's look at this. So first of all, the first FRQ that we're going to have for homework is there's a pendulum, and it asks you experimentally to determine the frequency of the pendulum. So I'm just going to go over the steps that I wrote out, what we would do. So step number 1 says find an equation that contains the quantity you want to find. Well, if I have a pendulum, so what I would say is the first thing you need to do is I always think about the equation, and you kind of go backwards from there. So it says find an equation that contains the quantity you want to find. Well, for frequency, for a pendulum, I know the period t is equal to 2 pi times the square root of L over G, and then I know frequency is equal to 1 over the period. So for that FRQ, all you really need is a stopwatch to determine, to measure the period. But anyway, and then from the period, you could find the frequency. So let's look at the steps here. It says read the problem looking for clues regarding the variables to be tested. Work your way from that equation through related equations until every quantity in every equation is either something you can calculate or something you can measure. Determine how to measure the quantities that you need. So you have to think about what's like the dependent variables. Decide what your starting conditions need to be. So again, your independent variables. And figure out what you need to keep constant. Those are the control variables. Set up your experiment and take data. So what you're going to do is, I don't know about on the computer, because I think it's going to be one where you're going to be typing. Even though you can take a picture and upload it like the homework on Google Classroom, I think that would be harder. So normally I would say sketch a diagram showing the lab equipment being used and label it. So write a procedure in paragraph form. So the keys to, when you write a lot, they don't want to read it. So keep it simple. Refer to the diagram, or you can explain a diagram. So again, you need to talk about what device you're using. So when you're writing a sentence, you have to say what device you're going to use, what it measures, what's the unit, include the variable. So you would say, for example, if I was measuring mass, I'm going to use a triple beam balance that measures mass in grams, and the symbol for that is lowercase m, and you would put the little m in parentheses. Or mass in kilograms, or then I'm going to convert it to kilograms. You have to be very specific about what instrument you're using, what quantity it measures, what the unit is, and then what the variable is. Okay, and that was the example I gave here. All right, number 5, calculate the results. Whenever possible, clearly state how to solve the desired quantity in terms of all the other quantities measured, or that have to be substituted into a derived equation. List all possible errors in the experiment, so systemic errors, information in the instruments, or observational, random errors again. Number 7, variables to mention, the constants, like what's a fundamental constant, what's a derived constant. Controlled variables, what they are and why. And then don't forget to say what is the independent and dependent variables. So when we talk about equipment, the example that they gave this year was the type where you check the little boxes. It might not be that type. That's probably much easier. So I'm thinking that's what they're going to do, but there have been ones where you pick the equipment, and there could be some different scenarios. So I don't think they're going to do that. So remember, if you want to measure length, use a meter stick or a ruler. Mass is a balance, weight is a scale, time is a stopwatch. An accelerometer measures acceleration. A motion detector collects position, velocity, acceleration of moving objects. A force sensor measures, forces. Photo gate measures speed. Well, we're not doing ammeters and voltmeters. All right. So photo gates, they measure free fall acceleration. We did that lab with that weird thing that had little lines on it, a little plastic thing. They said not to break. Studying the swing of a pendulum, that's the first one of your FRQ. Measure the speed of a rolling object. So the example that they had in the first FRQ was rotation. One of them is going to be rotation. So either you're going to design an experiment with rotation, or the first FRQ is going to be rotation. So there's been in several other AP lab manuals I was looking, there's been a bunch where you're going to do stuff with rolling objects. Like, does the mass make a difference? You try to do different shapes. So we'll talk about those throughout the week. Timing the period of a rotating object, measuring the speed of objects undergoing collisions. That could be another one because I saw a couple with collisions. So motion detectors are used for walking, toward or away. Dynamic carts moving on a track, objects in simple harmonic motion, which is not going to be on the test. Pendulum motions, objects dropped or tossed up, or a bouncing object. Force sensor is used, force and impulse during collisions. We're not doing simple harmonic. Frictional force, Hooke's law, and force on dynamics cart. So another thing that they might give you, my hunches, I don't know, I have hunches. So anyway, that's it. Okay, and then we'll do our first two designing experiment FRQs.